Geometric mean, altitude theorem. So this one's going to kind of follow along with the idea of the geometric mean. And it says, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. So if we look at the picture, we have CD, which is our altitude, and it divides this side down here into two segments. You have the left segment and the right segment. Now, I know they have this labeled, but I'm just going to call this one AD. I'm going to call that A. And DB, I'm going to call that B. And then my altitude, I'm going to call that X. Now, what it says the length of the altitude is the geometric mean of the lengths of the two segments of the hypotenuse. Which means, if you remember, we had A over X equals X over B. I think I might have changed around where the A and the B and the X are, but it's the same thing. I also called this theorem the heartbeat theorem. Okay, so think about a heartbeat or a heart monitor. If you're in the hospital and someone's on a heart monitor, doesn't it kind of go over, up, down, over, like a heartbeat, like doo-doot, doo-doot, doo-doot? So this one's kind of like your heartbeat, because as you trace along your heartbeat, you have A over X equals X over B. So A over X equals X over B, which essentially, if you're solving for X, that's your geometric mean. The way they write it in the theorem is that CD squared, which is your altitude squared, equals AD times BD, which again, this is your nth root, because you would have to solve this by taking a square root of the product of your two numbers. But I personally like to think about it like this. The other one is we have the geometric mean leg theorem. So the first one was the altitude theorem. This is the leg theorem. And when we're talking about a leg, we're either going to be talking about the leg over here, or we're going to be talking about the leg over here. So we're talking about the legs. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So there's actually two things going on here. The first one right here says that if we take CB squared, that's the leg, that's going to equal DB, the short one next to it, the adjacent, times AB, which is the entire hypotenuse. Now, if we do the other leg, then that would be CA, that's the other leg. So we take that and we square it, and that's going to equal the one next to it, AD, times AB, the whole thing. Okay, so now that we know that, let's skip the whole way to example 5. And example 5, letter A, says find the value of each variable. Now, option 1 here is to draw all three triangles. Remember, we kind of put a tick mark here, and then we would put 2 tick marks here. We would draw out the 3 triangles, we would circle 2 of them, and we would find their corresponding parts. You can still do that. But if you remember the altitude theorem, it's a little bit easier. So this one is the altitude. So I'm going to use the heartbeat. 6 over X equals X over 3. So 6 over X equals X over 3. The other way that it told us how to do it was to take the altitude, which is X squared equals 6 times 3. If you're using the flat out theorem versus if you're using the heartbeat. If you solve both of these, this one's going to be cross multiplication. X squared equals 18. Then I'm going to take a square root and just simplify my square root. So this is going to be 9 times 2. And then this is going to be 3 times 3. So this is going to be 3 times the square root of 2. That's your altitude. If you do this version, same idea, and then take your square root, and you get the same answer. Letter B, we have to solve for y. Now, this one is not the altitude because the altitude is right here, and that's not what we're trying to find. This one is the leg. So the leg theorem says we're going to take the leg and we're going to square it. So y squared equals. Then we take the adjacent side. The adjacent one is the 2. So 2 times, and then the entire hypotenuse. So the entire hypotenuse is this entire thing, which is actually 5 plus 2, which is 7. Then we would simplify. So y squared equals 14. Square root, so y equals, if we try to break this down, it won't break down. So we're going to leave it as the square root of 14.